Okay, class, we're about to start section 1.1 using qualitative graphs to describe situations. Now, a qualitative graph is a graph that indicates only the basic shape of a relationship. No scale is given. The axes are labeled with names of the variables, but no numerical values are shown. Okay, so basically this means no numbers are involved. Okay, now, the following people are waiting at a bus stop. Identify which person is represented by each point on the graph. Now, what happens here is numbers were used, but these numbers are just to signify who is who. This has no basis on what the graph is. So now, we look here. We can start off with the smallest person first, which is the infant. So we know the smallest person would be number 7. Now we go to the next tallest person, which would be Kathy. She would be 6. And then the next tallest is 4 here. Okay, 4 here would be Brenda. And the next tallest would be 5, which would, well, actually the next tallest here would be 1, which would be Dennis. Now, the next tallest, which would be 3, which we know would be Frida. The next tallest would be 2. Well, actually, let's take a look here. Let's just draw a line here. Huh. Yeah, it looked like the next tallest is 2. And finally, the tallest is 5, which is the teenage boy. So now we label them by their position on the graph. So now, let's scroll down here. It says example 2, an object is dropped from the top of a building. At first the object falls slowly, but as it continues to fall, it falls faster and faster due to gravity. The speed at which the object falls is increasing at a steady rate. Which graph represents the height of the object? Which graph represents the speed of the object? Okay, now, let's take a look here. Now, when you drop a ball, accounting for gravity, you know that ball is going to get faster. But when you initially drop it, it's going to start at 0. So, what represents this is A. It starts at 0, and as you see, it increases. So, A represents the speed. This would be your speed. And this axis here would be your time. As the time increased, your speed increased whenever you drop a ball. Now we come down here to F. Now again, when you drop the ball, you're going to start at the top and it's going to work its way to the bottom. And it's going to increase as the time goes on. It's going to increase, the height is going to decrease. So we will put height for our y value, and then we will have time for our x value. As the time goes on, the height decreases. Now, we scroll here to page 2. Now we have independent variable and dependent variable. An independent variable is a variable whose value determines the value of other variables, often but not always represented with x in algebra. A dependent variable, a variable whose values is determined by the value of the independent variable, often but not always represented with y in algebra. Let's take a look at A. The ages and heights of the people waiting at the bus stop from example 1. Now we want to find the independent and the dependent variable. The independent variable is the ages. So that will equal to our x in most situations. Because your height really has nothing to do with your age. You could have somebody that's 90 years old that's only 4 feet tall. So your height has nothing to do with your age has nothing to do with your height. So then we have dependent. which is the height. Now, your height can be affected by your age, just like an infant. We would expect the infant to be, less than 4 feet tall because they're a newborn. Now, we could write this out as a statement. Now, I'm going to do a little abbreviation. This B/C means because height depends on how old you are. Okay, now we go to B. Let h be the height of an object that is dropped from a building t seconds after it is released. So we would have t is independent. Because t represents time, and the height is dependent. And that is because the height depends on how long the object has been dropping. Okay, so now we go here to C. It says, let L be the length of your hair at D days since the last haircut. Now, days, represented by D, is your independent variable. And then your length of your hair, or we could just say length, which is represented by L, is your dependent variable. And that's because the length depends on how long it's been since the last haircut. So now we scroll down. Now we come here to the next page. It says how to draw a qualitative graph that represents a real world situation. Step 1, decide on your variables, which is independent and which is dependent. Step 2, think about where to start the graph. At the origin, with positive or negative values of the dependent variable. In other words, what is the y-intercept? Next, determine the shape of your graph. Will the graph increase or decrease at a steady rate or non-steady rate? And step 4, determine how the graph will end. At a specific point, will it go on increasing or decreasing indefinitely? Will it level off? These are all the questions you need to ask yourself when you're graphing. Now we come here to example 4. It says draw a qualitative graph for the situation. Let L be the length of your hair at D days since your last haircut. Okay, now we will have our length, which is dependent, so it'll be with the y-axis, and then we'll have our days, which is our D, which is the independent, which will be on the x-axis. Now, if you look here on the first day, you know where the days and the length meets, that would be your origin. Okay, now, when you get your hair cut, most people do not get their hair cut bald. So you would not put a point at the origin. The origin means you have absolutely no hair on your head. So you would go up just slightly because remember, you did get your hair cut. Okay, so now, after you got your hair cut, then what you have to do is this here. You know your hair length is going to increase as the days go by. So you should draw a graph increasing. And put an arrowhead because it will increase indefinitely. Now it should be a straight line. So now we go down here to B. The deer population P grows during spring and summer months due to the birth of fawns, but declines during fall and winter due to hunting and starvation. Draw a graph showing at least 3 years. Okay, now first thing we would need to do, we could list our independent variable, which would be Y, which we know is years. Next, we would list our dependent variable, which is P, which is our population. Okay, so now, this is what we would do. This graph here, of course, we know we will have some ranges here. So, we will have, let me put a few points here. Now, these ranges will go as so. This could be the cycle of the first year, cycle of the second year, and cycle of the third year. That's all we want to do is go by this time. Now remember, we're starting off with a population. So at 0 years, we still will have a population of some deer. So let's just start here. Now remember, we have during the fall and winter, the population declines. Now we know typically, well, if we're starting at the beginning of a year, we know winter comes first. So the population is going to decline. And then it's going to rise again, only to decline, only to rise again, only to decline, only to rise again, only to decline. And that's where we would end this at. So this graph here goes down, up, down, up, down, up, and it will continue this cycle. So this is the end of section 1.1.